Hello Professor, this is Venkateshwar Vejala. Now I am going to show assignment 4 which you assigned for this week, and you've been an assignment tell us you provided a Python file heap.py which you used to construct a min heap structure and develop a linked heap data structure in the file name linked heap extension appropriate. In heap in this we I show you the heap must support the following interfaces above interfaces which heap.py like insert key comma value, delete peek and add key comma value, remove min is empty and length of the heap. And coming to the point, in Jupyter notebook created a class node. In class node we define a function init self key comma value which shows the self dot key equal to key, and here parent node self dot parent equal to none, self dot child equal to none. Here returns a reference to the parent node, gets the element, return self dot value, and after that return self dot parent returns a reference to the left child node. After executing, it gets define get left by self, and after returning self.leftChild, it returns a reference to the right child node, which shows define getRight self, which that when executing it returns self.rightChild. After the returning a self.rightChild, it sets the element of the node, which this will work if the element has not previously been set in currently none. And after defining a function set element self comma new element, it's if self dot element is none, self element equal to new element. That means if self dot element equal to self new element, sets the parent node and returns the old parent child, that this node used to point to define set left of self comma new parent, and when it returns to the old parent, and the sets the left child node and returns the old left child, that this node used to point define set set left new left, which equal to returns the old left. After setting the right child node and returns the old right child, that this node used to point define set right of self comma new right, which shows whole right equal to self dot right, and it returns the statement all right. And defining straight self, we give the output element of strength straight of self dot element, and has the parent of straight self dot get parent is not none, and straight str of self dot get left is not none, and gives the output has right str self dot get of right is not none, returns output. And here I created another class linked heap which define init function of self dot read equal to CNA values of self dot root equal to none, and self dot size of the root equal to 0, which means the size of root is 0. And here we define a definition insert self comma key comma values, which means we can insert the key comma values in the node, which shows new node equal to node of key value, else if self.root is none, self.root equal to new node. That means if the self root is none, a new it, it directs to new node. Or here we else else statement which used to move the output to while node dot q, current node equal to node q dot pop or pop 0. If current node dot left child is none, new node dot parent equal to current node, and you apply break function. If current node dot right child is none, we we get the new node dot parent equal to current node. Else, we if in other scenario we have we use else statement. Node q dot append, which appends the values of the current node left child, and self heapify up new node, which that means here we heapify the new node of the current node left child, and left self dot size less or equal to 1. We define a delete function self. If self dot root is none, and program returns to none. If last node equal to self dot root, self root value equal to last node dot value, which means self dot root equal to none, self dot size equal to 1, which returns the minimum value of the key and minimum value of the node. Define peak. Here we, we define the peak function. If self dot root is none, we return self dot root dot key comma self dot root dot value to the statement. If, and after peak we define heapify up, which means the node self dot root and node key goes to the parent key. Node dot parent dot value equal to node value of node parent value, which shows the node equal to node dot parent. After defining heapify down, which shows the node self comma node, the left child is not none. If node dot right child is not none, and node dot right child key gives the min child equal to node dot right child. And after we use else statement to break the heapify down, and if we want to remove the last node of the program, we use define remove last node, which define node q equal to self dot root. If current node dot parent is not none, if current node parent dot right child is not none, else current node dot parent dot left child equal to none. By here it returns to the current node, which remove from the last node. Define print preorder, which is used to print the preorder of the node while node q. Print we entering a value of print node q of 0 dot value, which means if current node dot left child is not none, node dot q append current node left child, which means which append the node of the left child. After linked heap, insert the values of 4 comma 4 and 3 comma 3, 2 comma 2, 5 comma 5, 1 comma 1, which you assign in the values of the heap, and we enter the print statement print preorder, which shows print 1h dot peak, which lh dot delete, print values in the heap, which helps to print the values of the heap which we given. Print preorder lh dot root. After printing lh.peak, the value should be like values in heap should be like shown like this: 1, 2, 3, 5, 4. 1 comma 1 values in heap. It shows after executing the values in heap, it shows 2, 4, 3, 5. 2 comma 2. And after now we can I will show you. Add key comma value, remove min is empty and length which which is stored in the heap. For to show that, I created a class node and define a function get element self. Define get parent, define get left, define get right, and I created a class name priority queue which define init self. Define add self comma key comma values. Here I define remove of self which used to remove the root of the self. Define min. If self root is none, return self.root.key. And here I define is empty self. Return false. And here I define heapify up. And again I define heapify down. Else break the condition and apply define remove last node which used to remove the last node of the heap. After defining, we return the current node, and we have defined print preorder which used to print the values of heap in preorder type. Here define length start which used to define the length of the heap which starts the heap. Return count. Priority queue print pq is empty which gives the values pq. If we enter the values of pq.add 11 comma 11 and pq.add 7 comma 7, pq.add 8 comma 8, 6 comma 6, 5 comma 5, 9 comma 9, 4 comma 4, which we can use print function to displaying the values in the priority queue, which print preorder pq.root. After we use the statement print pq is empty. After pq to find the print the node total nodes in the priority queue length of pq. To remove pq.remove print displaying values in the priority queue print preorder. After that print total nodes in the priority queue length of pq. pq.remove displaying values in the priority queue. We use the print statement of total nodes in the priority queue length of pq, and the output shows like true. Displaying values in the priority queue are 4, 6, 5, 11, 7, 9, 8, which we given at the initial insert of the values. And after displaying the value total nodes in the priority queue are 7, and here it displaying the values in the priority queue 5, 6, 8, 11, 7, 9. And after applying the priority queue displaying values in priority queue 6 of 6, 7, 8, 11, 9. After priority queue goes to 5, it displays the values of 7, 9, 8, 11. After the heap goes to the total nodes in the priority queue are 4. Thank you, Professor.